Hi, we're going to spend the next few minutes talking about what third grade students in College Station ISD will be talking about and learning about in their math class for the first 9 weeks of this school year. This is actually part one of the first 9 week video. And so after you watch this, you could go back and look for part two so you can hear about everything that they'll be doing this 9 weeks. So here's an overview of the first 9 weeks. They're going to use place value to solve problems involving addition and subtraction. And that's what we're going to cover here in part one. And then in part two, we'll be talking about summarizing data to solve problems. So it's about using graphs. So in place value, they're going to compose and decompose numbers up to 100,000 as a sum of so many 10,000, so many thousands, so many hundreds, so many tens, and so many ones, using objects, pictorial models, and numbers. And compose and decompose just means to put things together and make the number, or to take a number and take it apart, to decompose it. So down here you see a few examples. If I have 58,923, I can represent that as 50,000 plus 8,000 plus 900 plus 20 plus 3. Or I could represent 58,923 as 5 10,000s, 8,000s, 900s, 2 10s, and 3 1s. And you notice when I say 58,923, I do not use the word and in there anywhere, because when we're reading numbers and we say and, that implies the presence of a decimal point. And since there's not a decimal point in this number, I don't use the word and. And then at the bottom, we see a picture, a pictorial model of 4,563. And so we have 4,000 cubes, the large cubes. We have 5 flats, 500s blocks. We have 6 rods, or 6 10 sticks. And then 3 small cubes, 3 unit cubes for ones. And so that's a pictorial representation of 4,563. And the students need to be able to go back and forth between any of these representations, the standard form, the expanded form, the representation at place value, or the pictorial model. They also need to be able to represent a number on a number line as being between two consecutive multiples of 10, 100, 1,000, or 10,000, and use words to describe the relative size of numbers in order to round whole numbers. And in the past, we've tried, teaching students to underline a digit and then circle it. And the problem is that they're just trying to memorize steps and they forget it very easily. And they don't really understand what they're doing with rounding. So this is designed to really get them to understand the concept of what rounding is and how we do it. So for instance, on the top number line, if I asked a student to put a point that represents 582, they would need to know that 582 comes between 500 and 600, and they need to know that it should be placed closer to 600 than to 500. And so then we have the conversation that if I was rounding this to the nearest 100, I would round it to 600 because it is closer to that multiple of 100. We could do the same thing with a number down there where it's counting by 10,000s. But if I had 58,923, again, it'd be between 50,000 and 60,000, but much closer to 60,000. So that's the number that it would round to if I was rounding to the nearest 10,000. So once they understand the concept of rounding and they've had some practice with it, then they're going to round to the nearest 10 or 100 or use compatible numbers to estimate solutions to addition and subtraction problems. For instance, John had $512 in the bank. He earned some more money and now he has $735 in the bank. About how much money did John earn? And since it says about, I know I'm looking for an estimate, a number that is close to the exact amount, but not necessarily the exact amount that John earned. So here I could round to the nearest 100, and 512 would round to 500. 735 would round to 700. And so 500 plus something else equals about 700. And so when I worked that problem, I realized that it's 200, that he earned about 200. That it's not exactly how much he earned, but it's a good estimate. It's approximately how much he earned. And so we want the students to round the numbers before doing the calculation. And when they see things like the word about or approximately or to the nearest 10 or nearest 100 or nearest 10,000 or the words best estimate, then that clues them into the fact that they're looking for a good estimate. They're not looking for the exact amount. They're also going to compare and order whole numbers up to 100,000 and represent the comparisons using the symbols greater than, less than, and equals. And you can see in the first 4 rows that we are just comparing 2 numbers and using greater than and less than symbol. But on the last 2 rows, we're actually comparing 3 numbers. We're comparing and ordering those numbers, and we could have done more than 3. So that's something new, something that they didn't really do in 2nd grade, where they're comparing more than 2 numbers using those symbols. They need to be able to write the symbols in the correct spot, but they also need to be able to read these comparisons to say 452 is greater than 271 and that 271 is less than 452. They need to be able to solve with fluency 1-step and 2-step problems involving addition and subtraction within 1,000 using strategies based on place value, properties of operation, and the relationship between addition and subtraction. Additionally, when they're solving these problems, they need to be able to represent 1- and 2-step problems involving addition and subtraction of whole numbers to 1,000 using pictorial models, number lines, and equations. When it says a 1-step problem, that means they just had to do 1 calculation to arrive at the answer. If it's a 2-step problem, then they're going to have to do 2 different calculations to arrive at the answer. So here's an example of a 1-step problem. Mary had 456 stickers. She put 285 of her stickers in a sticker book. The rest of her stickers are in her desk drawer. How many stickers does she have in her desk drawer? And so what I'm using here is a part-whole model, sometimes also called a number bond model. And the box at the top has the total number of stickers that Mary has. She has 456 stickers. And so we're going to put 285 of her stickers in a sticker book. So you can see how it branches out into, the total branches out into 2 parts, one of which is labeled sticker book and the other one is labeled desk drawer. So she's putting 285 in the sticker book. So we're going to look in the ones place and say, well, we need to put 5 down here. So we crossed out 5 out of the total and moved them down into the sticker box or sticker book. Now we have in the total 400 and we did have 5 tens. Well, we need to take away 8 tens and put them down in the sticker book, and we only have 5 tens. So we cross out one of the hundreds and trade it for 10 more tens. So then we end up with 15 tens, and we cross 8 of them out and move them down into the sticker book. So now we were left with 3 hundreds, 7 tens after we took away those 8 tens, and 1 1. So now we put 5 ones down there, we put 8 tens down there. Now we need to put 200. So we just cross out 2 of the hundreds and move them down into the sticker book. So now we have 285 in the sticker book. So then we know that everything that didn't go in the sticker book is going to go into the desk drawer. So we cross out everything in that top box and move it down into the desk drawer. So I can see she put 285 stickers in the sticker book and she put 171 stickers in her desk drawer. So this is a pictorial representation of some base 10 blocks. So the students could draw this picture, or in class we might have these base 10 blocks and they just manipulate them and move them around. And here's an example of a 2-step problem. There are 54 third graders and 38 fourth graders in the school choir. Then 22nd second graders join the school choir. How many students are in the school choir now? So to solve this, if they were just doing the equations, they would add 54 plus 38 and arrive at an answer of 92. Sorry, I'm doing it in my head. And then they would take that and add the 26 to it to get their final answer. What I've created here is a different part whole mat. And so we have a bar that goes the whole way across, and that's where we're going to put the total. And below that, we have a bar that's split up into 3 parts. And we put 54 in one of them and labeled that 3rd grade because 54 3rd graders are in there. 38, and we label that 4th grade because that's how many 4th graders join the choir. And then we have a box that we put 26 in and label that a 2nd grade. And if I put all those boxes together, then that would be the total. Here's another 2-step problem. Kelly baked 135 chocolate cupcakes and 149 vanilla cupcakes for the school picnic. When she was carrying the cupcakes into the school, she dropped 18 cupcakes and had to throw them away. How many cupcakes does Kelly have for the school picnic now? So you can see that bar, that line that goes across the top, says that if you go the whole way across, that's the total. And then the bar below it says 135 chocolate cupcakes, 149 vanilla. And if you put those together, that would equal the total. Below that is the bar that says that 18 of the cupcakes got thrown away, and then the rest of them were still left for the school picnic. So we would add the 135 plus 149 to get the total, and then we'd have to take away the 18 to find out what's left. So we do addition and then we do subtraction. And they are also going to be working on finding the value of a collection of coins and bills. And in 2nd grade, they only added coins up to $1. In 3rd grade, the coins could exceed $1, and they also have bills, $1 bills, $5 bills, $10 bills to add in there to the total. They're also going to determine the solution to problems involving addition and subtraction of time intervals in minutes using pictorial models or tools, such as a 15-minute event plus a 30-minute event equals 45 minutes. For instance, Ralph ran on the treadmill for 28 minutes. He lifted weights for 19 minutes. How long did Ralph exercise today? So they would have to add the 28 minutes and the 19 minutes. Here's another example. Lance started his homework at 5:20. He worked on math for 35 minutes and he worked on spelling for 20 minutes. What time did Lance finish his homework? So here we're using a pictorial representation that's a kind of time number line. So we put a dot to show that he started at 5:20. Then we jumped 35 minutes because that's how long he worked on math, and that took us to 5:55. And then we know he worked on spelling for 20 minutes. But if we just did a 5-minute hop, that got us to 6 o'clock. And then out of that 20 minutes, we still have 15 minutes left. So we hopped from 6 o'clock to 6:15, and we know that's the time that he finished. Renee went to the carnival tonight. She spent 40 minutes riding rides and 30 minutes playing games. She left the carnival at 8:15 p.m. What time did Renee arrive at the carnival? So this time we know the ending time. So we started at 8:15, and we know if we hop back 15 minutes, that gets us to 8 o'clock. So out of that 30 minutes, we still need 15 more minutes. So we hop back another 15 and land on 7:45. And then if we hop back the 40 minutes she spent riding on rides, that takes us to 7:05. So that's what time she arrived at the carnival. If you want to get some practice for your children, you can go to the CSISD website and click on curriculum, and then math, and then parents, and there are resources in there listed by topic. And if you click on a topic, it will take you to a list of really good resources, really good websites that you can have your child visit to practice the topic that you clicked on. In the topic word problems, you'll find Thinking Blocks, which is a fabulous site for practicing addition and subtraction and models of addition and subtraction. So thank you for listening. There's going to be a new video at the beginning of each 9 weeks so you can keep up with what's coming up. And if you still have questions, contact your child's teacher or the math specialist on your child's campus. If you go to this website, you'll find a list of math specialists so you can find out who is on your campus and contact them via email or phone call. And again, thank you for listening and have fun learning math with your child.